When it comes to the future of building design and technology, what do you think about first? AI-driven building management? Maintenance supported by augmented reality? Smart energy management systems? IoT sensors for monitoring and control? Everyone probably pictures something a little different, depending on what they think will make their building work best. When VoltServer thinks about the future, we have our own picture in mind. And it's one that starts with reimagining how buildings are powered. In fact, we have a bold prediction to make. Within the next 2 decades, we believe that fault-managed power distribution will become the standard for new building design. Why are we so confident about this? Let me explain. Many of the innovations I just mentioned, such as AI and augmented reality, require lots of power and lots of data to function. And while the technology that shapes where and how we live, work, and play is advancing rapidly, the power distribution methods that support it haven't changed in well over a century. Yes, you heard that right. Right now is the time for building owners to rethink their approach to powering their facilities. The typical approaches you've come to rely on are no longer your only option, and they're not positioned to serve you well in the future. As building design and operation evolve, so must your approach to power. Otherwise, you'll be left in the dark, literally and figuratively. There are some powerful forces coming together behind the scenes to create somewhat of a perfect storm. Energy demands are rising, sustainability is becoming more of a priority, labor is harder to find, and supply chains aren't easing up. As these challenges converge, their combined impact is compelling building owners to rethink how they design, operate, and power their spaces. So what are these forces anyway? Let's talk about them in more detail. First, electricity demands are on the rise everywhere. In healthcare, education, manufacturing, commercial real estate, data centers, and the list goes on. There are not only more people and devices attempting to connect, but also more applications that require constant uptime. We rely on power and data for nearly everything we do today, from running a meeting and sending invoices to ordering groceries and streaming entertainment. And energy use will continue to grow, not shrink, as the increase in smart devices creates more energy-intensive loads. More demand will also be shifted to the grid as actions to limit natural gas take hold. And much of this power will need to reach across long distances. Consider EV chargers in remote locations, for example. The demands of our high-energy world are difficult for our conventional electrical infrastructure to keep up with. Our grid and the systems that sustain it wasn't built for this level of demand. And our aging building stock isn't made for it either. The U.S. Department of Energy says the power grid will need to double in size by 2050. Its reliability is on the decline as systems age, and this deterioration can lead to unplanned outages, a reduction in load-carrying capacity, and higher maintenance costs. But expanding the grid won't be easy. Demand is rising faster than new grid capacity can be added. Much of the existing grid is outdated and not designed to handle the increased loads and integration of renewables required by modern energy demands. Plus, it can take years to source components like transformers that are needed to grow or modernize the grid. These are all the reasons why our current infrastructure isn't built to keep up with demand. As energy needs escalate, another issue rises to the surface. Sustainability is becoming a bigger priority. Building owners are feeling the pressure to lower energy consumption, reduce waste, and work toward net zero targets. They're realizing that sustainable buildings not only reduce environmental impact, but also offer financial and operational advantages. Looking ahead, power distribution will need to accommodate higher and more variable loads as buildings strive for net zero emissions and work to improve efficiency. Traditional power infrastructure will struggle to keep up with this dynamic. It's designed to support predictable, steady energy use and less complex demands. Older systems may also lack the ability to efficiently manage the dynamic distributed energy flows that come along with more energy-efficient building technology. In other words, the grid will struggle to deliver the reliability, resilience, and efficiency that modern and sustainable buildings will require. Another factor to consider is the availability of qualified labor. This is a major concern in many industries, including power transmission and distribution. Labor shortages are making qualified electricians hard to find, but they're the only skilled professionals authorized to work on today's electrical systems. As building owners wait on labor, they have no choice but to delay progress when they can't find the people they need. According to NECA, nearly 30% of union electricians are at or close to retirement age. The Bureau of Labor Statistics estimates that we'll need to add 80,000 more electricians to the pool every year through 2031 if we want to try to keep up with demand. The scarcity of electricians is having a significant impact on the future of building design, as owners seek other ways to complete projects and keep systems running. Finally, we have supply chain disruptions to contend with, and they aren't going away anytime soon. As I mentioned earlier, it's taking 2 to 3 years for electricians to source transformers and other critical components required for grid maintenance and expansion. This environment of uncertainty and delay is giving building owners no choice but to look for other options, because no one wants to wait years for a single component. They want options that are easier to source, install, and maintain.